What's wrong?
It's not getting hot.
I can relate. Let's bring it down to the bench for a closer look. This is a mid-tier Hot Tools hair straightener, model HT7100. With it plugged in, there's no signs of life. Now this swivel connector undergoes a lot of torsion and stress, so we'll single that out as the most likely flaw in this device. Undo the Phillips screws pinned tightly to the cord coupler and remove the collar. With the cord plugged in, let's use a multimeter to test the voltage coming out of the 120 volt AC outlet. Touch one probe to the outer band and the other to the pin. 120 volts, which rules out this piece as the problem. Okay, let's test the coupler to see if the voltage is appropriately passed. Again, 120 volts, which rules out this as the problem component. 120 volts. We'll have to dig deeper. Unscrew the tongue connector and pop it out. Remove the protective plate on the power side. With that plate off, we'll toggle the power switch, but it still doesn't deliver any heat. Following the current from the coupler brings us to this main power PCB. From here I notice a circuit which loops in a fuse. Testing for continuity across the fuse, let's place a probe on the black and a probe on the red wire. Aha! Continuity has been compromised. That means the source of our problem may lie on this circuit. Following the wires, the thermal fuse rests underneath the hot plate on the power switch side. We'll snip it out and connect the two wires, effectively bypassing the fuse, and see if that turns on the device. Continuity checks out at the point of the power PCB. Aha!
Flicking the power switch gets us LEDs, sound, and heat.
Yep, that's going now.
So the thermal fuse was the source of our problem. For completeness, let's verify continuity on the ribbon cable. The beep indicates a reliable connection. These are 240 degrees Celsius 10 amp 250 volt thermal fuses, which are available on eBay for about $1 a piece. We'll wrap the fuse terminals behind its metal shielding plate, but one thing to keep in mind is the shielding is conductive. So if we just placed it on here, the protective fuse could blow, but the signal could still bypass the fuse and represent a fire hazard. So we'll address this safety issue in a moment. Before connecting it up, we'll slip a wire shrink over each stripped wire. We're going to use a metal terminal end connector, not solder, to bridge the fuse. Slip the wire and the fuse end inside the metal tube and double clamp connect. Aha! This time we regain continuity across the thermal fuse. Now because this thermal fuse pops at 240 degrees Celsius or thereabouts, let's wrap a damp rag to insulate while using the heat gun to shrink the wire. We'll do a quick final test before reassembly. Now remember when I mentioned that conductive shield? In order to protect the device, let's wrap heat-resistant tape over the uninsulated portions of our fuse before popping it back in its home. Now it's not necessary, but in order to better accommodate the wires, I tucked the ones on the fuse circuit beneath the PCB. Let's put it all back together. As long as I've got a moment, I want to address what I believe some of you may be wondering. Why didn't he just solder in the thermal fuse? The reason being is under these high temperatures, you run the risk of melting at least traditional rosin core solder, which would terminate the connection. I appreciate all your likes and subscribes. Thank you for visiting my channel, and I hope to see you back next week.
Great success.
I hope her hair is curly.
Hey!
Hey, got it!
Oh my gosh, you fixed it. I thought it'd be bigger.
Just let us go in the house. Come on.
Ugh!
What is it?
It's not getting hot.
Let's do that again.
I thought that's what I was supposed to say.
Maybe I screwed that one up.